Hello and welcome back to this latest video in the electronics series. In this particular video we'll want to cover briefly over the different aspects of soldering and desoldering. Soldering in terms of putting components onto PCBs, that sort of thing. Soldering components onto the Vero board, and desoldering, basically the opposite, removing those components from a PCB, which is the sort of thing you would need to do if you're doing repairs. There's different ways to remove components from a PCB or from a Vero board for that matter, and I'll go through a few tools that I use to accomplish that. We're going to be running through a few things here. Through hole components. I'll cover basically that standard PCBs, the things that we're probably mostly familiar with, where the component drops into the board and it goes through holes and it's soldered underneath on the underside of the copper board. We'll solder a few components onto PCBs there. Later on in the video, in the second half, we'll be covering surface mount devices, SMDs. I'll show you a few examples of soldering components onto boards and that sort of thing using hot air, and also using a standard very fine soldering iron tip to do that as well. Again, there's different ways to do that. I'll cover different types of solder. You have various types of solder, leaded and unleaded types. There's a few there, and different gauges as well. You can also get very high melting point, like this particular one here is designed for aluminium work. For soldering aluminium. So there's different types of solder with different melting temperatures and what have you, and I'll talk a bit more about that later. Different types of soldering iron, which is actually very important to select the correct tool for the job. If you take anything away from this video at all, it's choose the right wattage soldering iron with the right size tip, depending on the work that you want to be doing. If you're working on PCBs, that sort of thing, down to a very small component rework, then you'll want a fine tipped soldering iron, and you don't want it to be too hot, something like 18-20 watts, something of that nature. You don't want to be going up to 40s and 50s and 60 watts, because it'll just burn everything. Especially fine copper tracks, they'll just burn out. So it's important to get the correct soldering iron with the correct tip, with the correct soldering iron tip, and I'll cover a bit more about that later on as well. So that's what we're going to be talking about in this video. Okay, let's have a quick look at some tools here. On the left we have a reasonably decent, not top of the range, but good enough for the job, soldering rework station. You have a soldering iron with a very fine tip on this one. It's actually got a very fine tip. These tips can be changed. These are copper tips, and these can be replaced and changed depending on the size of the tip that you actually want, depending on the work that you're doing. It also has a little vacuum smoke unit here, which takes away the smoke from the tip. I sometimes use that depending if I'm generating a lot of smoke in the room, and basically that sucks it up away from the tip, so you don't actually have to breathe it in. That's the fumes from the flux when the flux is actually melting. It can produce quite a bit of smoke. So that's the actual iron itself. The base unit itself regulates the temperature. We'll have a temperature control here. It's, it goes from about 250 degrees all out to about 450 degrees, something like that. You'd never go that hot really. I tend to hover around about 400 degrees, depending on what I'm working on, usually down to about 350 degrees, something of that nature. That seems to work quite well for what I do. So that's the soldering iron side of things. It also has this thing on the end here, which is a hot air gun. These have replaceable nozzles. I've got a selection of different nozzles. You can change those depending on the size of the hole that you want in the end. If you're doing really fine work, you might want to use a very fine nozzle with a very small hole on the end of it there to give you a very accurate hot air beam, if you like, or a hot air blast. Whereas this one's a little bit bigger, and that's more acceptable for general work. It has a pump in here. I'll switch it on. So I've actually switched it on now. You see the temperature will start to rise here. This particular one it's the model 968, and basically it defaults to 90 degrees, and you can turn it up and down with these buttons. I normally go up to about, 280, 300 degrees, something like that. It's usually hot enough for most work. You can go hotter than that. And it has a pump in here with a variable control to set the air pressure. That's how fast the air is coming out of the tip there. You can regulate the airflow using this control valve here, and that's for surface mount work. We use hot air a lot for surface mount work, and we tend to use the normal soldering iron for standard PCB work, although you can use that for some surface mount work as well. Okay, so that's what a class as a rework station, because you can use the hot air gun to remove chips, surface mount chips and components from a board, and you can also use it to put them on as well. So these are really handy. They're not that expensive. You're looking at about £100 something like that from one of these Chinese outlets on eBay or something. There are plenty of people selling these, and there are different variations. This is the 968. There are different versions of it which look quite similar, basically do the same job, and there's quite a lot of them out there. If you wanted to go up from this, you're talking about a Weller soldering station, which are considerably a lot more money, not necessarily that much better, maybe a bit more control, but these are sort of adequate for most home hobbyist type and even professional work for that matter. You've got a little sponge on here which you normally keep wet, and that's used for cleaning your tip, so you can actually just give that a wipe every so often and take off all of the residue off the end of the soldering iron, all of the bits of gunk and flux and what have you. Keep it clean. And that's the rework stations. That's a soldering iron, that's a hot air with a pump and a vacuum unit as well to take away the fumes, all in one box, so that's a really handy piece of kit. This unit on the right, this is kind of the opposite. This is a desoldering unit, if you like, and what this is it has a gun here with a very fine tip nozzle. Again, you've got different size nozzles, and this gets pretty hot. At the moment it's set to 381 degrees. Doesn't have to be that high, but for a lot of work that's where I aim for. It's a bit like a soldering iron, but instead of having a tip, it has a hole on the end, and what you do is you put that tip onto a PCB, and I'll show you this in a moment, and then you can actually heat up the component terminal using the hot element here. Press this trigger, okay, and it basically has a vacuum pump inside of the unit, and that sucks the solder right through, and it ends up in this little glass tube at the back here, which you clean every so often. Mine's probably about ready for a clean. I've been using it a lot. And this is one of my favourite tools actually, because if you don't use one of these, you have to use a spring loaded solder suction tool, which are quite okay for small jobs, but once you've got a lot of desoldering to do, like if you're doing a chip with lots of pins, or if you just do a lot of work. I do a lot of audio equipment. Sometimes I have to change lots of faders, and it could be hundreds of terminals, and doing that with a spring activated release gun really starts to hurt your hand after a while. It's quite intense, but with this you can get through it really quick, and it's a lot cleaner as well. It's not slipping around or anything with the vibration of the solder sucker unit. It's much more reliable. Again, these are not that expensive. You're looking at about £80 or £90 for the whole thing, and if you're doing a lot of desoldering or repairing work, these are excellent, really worth it. Again, cheap sellers from China on eBay selling these things. This one is the ZD915, but there are lots of variations. So we've got soldering, hot air for surface mount work, and we've got desoldering, the desoldering station tool there. So another handy piece of kit is one of these, and this is a hot plate. It runs on the mains, you just plug it in just like the other units. It's basically a temperature regulated hot surface. This is an aluminium block in the top. What you can use this for is you can put your PCB on there. I'll just pretend I'm going to do something with this board and just put that on the top, and what we actually do with that is heat up the entire board up to about, say, I don't know, 150 degrees, something like that. Not hot enough to necessarily melt all of the solder connections, although if you want to do a full-on reflow with brand new components on a new board, you could take this up to like 250 degrees, and it would actually melt all of the solder on the board and solder all the components at the same time. That's a little bit more advanced, and it takes a bit of skill to get it to work. But what I tend to use this for is, like I say, I'll take it to about 150 degrees and simply heat up the board without the solder melting. The reason why you would want to do that is because some boards are very difficult to solder and desolder, even with the desoldering station and what have you. As soon as you put the soldering iron onto the board, if the board's very cold, with a lot of copper on it, a lot of copper surface area, it saps the heat away from where you're trying to actually solder or desolder. So it can become very difficult to solder on cold boards with big heatsink areas, especially when you get like multi-layered boards with a high amount of copper. It just behaves like a heatsink, and as soon as you actually put the soldering iron on, you just don't get enough heat and the solder doesn't flow properly. So using a heat plate or a hot plate, you can bring the ambient temperature of the board up before you start to do any work on it. You can get it up to about 150 degrees or something like that, and then as soon as you bring in any extra heat from your soldering iron or from your hot air gun, it melts straight away, and you don't have any problems with the board taking the heat away from the area of interest that you're trying to work with. That's what I use the hot plate for. Very handy piece of kit, especially for problem boards, like larger boards with lots of copper, Smaller boards you tend not to really have too many issues, you don't have to preheat them. But bigger boards with lots of multi-layer surface mount, that kind of thing, lots of heat sinks on the copper and everything, you have a real problem trying to get the board hot. That's where these come in very useful. You can also use these for populating a surface mount board, getting all of your components on the board and put it on the surface. Take this up to about 250 degrees, something like that, for a couple of minutes, and you can actually watch what's going on, keep an eye on it, move things around with a pair of tweezers or something like that. Really get your hands in if you have to, being very careful because it's very hot. Solder all of the components at once, what we call flow the components onto the board, if you like. But I tend to use this for repair work, and I tend to use it for getting the ambient temperature up first to make it much easier and more controllable to do to do standard soldering work with, removing chips, doing repairs, that sort of thing. Without the hot plate, it's very difficult. If the board is big, full of copper and very cold, you just can't really work with it very well. Let's have a go with the desoldering tool. Like I said before, there's different ways to do component removal on through-hole component boards. One was to use the manual spring-loaded desoldering tool. These are quite cheap, they're only a couple of quid, and and they do the job. But like I was saying earlier, if you've got a lot of connections to do, there can be a problem. I've got a little board here, an old board out of an old Yasu radio, it doesn't work anymore, so we can have a bit of a play with it and pull some parts off and stuff. So let's have a play with that. Let's try removing a component or two. Well, if we have a look at the board, I've got a couple of capacitors on the end here, a couple of mica capacitors. Let's just say we want to take one of those off and change it for something else. Get the old soldering iron out. We'll try just desoldering one of them. All I'm really doing is heating up one of the legs and using the soldering tool. Having pressed it in, you see how that works on like a spring, on a spring mechanism. Okay, heat up the joint and then suck the solder away. So let's do that. Heat up the joint, suck the solder away. Okay, do the other side. It's taking a bit more heat because there's a large copper area. And suck that away again. Now, it's kind of worked. Do it again. Like that. Theoretically, with a bit of luck, that component should now come out. You see that? And it's as easy as that. So with the right solder suction tool, and these do the job. It's a bit awkward. I had to use a little bit of force to pull that out. I don't know if you noticed. It didn't just like come out very easily. It took a little bit of work to get the thing out. So yeah, it does the job, but it's not brilliant. Now let's try the desoldering tool that I showed you earlier. Here's another capacitor, another one right next to it there, another silver mica. Let's pull this one out. Only this time we're going to use the big boy. So let's go for this. And now all you do with this is push it onto the terminal of the component. I hope you can see all of this. Push it onto the terminal, melt the solder, and then press the trigger. So as soon as it starts to melt, or once it has melted, press the trigger. Okay, that's melted. Okay, done. Let's do the other terminal. That's melted. Done. Let's see how this comes out. Can you see it's already actually loose? Can you see that? No force whatsoever. Totally loose. Now, the reason why it's good if there's no force needed to remove the component, it means you're not stressing the board, you're not stressing the PCB tracks or anything like that. And if this was a double-sided board, in the holes you actually have conductive, if you like, areas that go from the top of the board down to the bottom of the board. And those can be actually pulled out if you have to use too much force. If you've got to yank the component out or use excessive heat or whatever, you can damage the board, and then you've got a problem actually putting the component back in again if you want to repair the board. It's better if you don't need too much force to actually remove the part. And as you can see with the desoldering station, as opposed to the cheap hand tool, it does a much better job. And it's much neater as well. Okay, so let's put the component back. Let's say we had to change this, argument's sake. This is an example. Put the component back in the board. One simple tip is to, once you put the component in, is just to bend the legs very slightly. Give them a little kink just at the end. And what that does is, I just use my fingers. I just get your fingernail in there or whatever. You could use a screwdriver, I suppose. Doesn't really matter. And just give it a little kink. And what that means is that the part won't fall out the board. It's not soldered yet. You can see it's loose, but it won't fall out. Okay, and that's really all you're doing. You just put it into place. Try and make this as visible as possible. get the solder. This is standard leaded solder, what they call 4060 composition. Get the soldering iron, and we're set to about 400 degrees at the moment. At least that's what it says on the front. I think it's actually not as hot as that. Let's do a little bit of soldering here. So bring the soldering iron to the joint and feed the solder in at the same time. Okay, so heat up the joint, put the solder in, you'll see the smoke. Right, that's done. You don't want to be putting too much heat on there, like don't hold the soldering iron on for too long or anything. So I'll do the other side of the capacitor here. Okay, so heat the joint, push the solder in. You don't need much, a couple of millimeters of solder. Hold that on for a second. There, that's done. So that component is now soldered back into the board. Let's do the other one. Put that back in as well. Okay, just push it in, bend the legs a bit. Okay, so it doesn't fall out. And here we go again. Get my hand out the way so you can hopefully see what I'm doing. Okay, that's good. Next side. I'm holding this side on a little bit longer, and the reason for that is we have a copper ground plane here, and it's taking the heat away. Remember I was saying earlier about, you know, sometimes you have to bring the board up the temperature first and then it allows it to solder. Well, this was starting to have that problem. You know, there's quite a lot of copper around here, this green area. It was taking the heat from the soldering iron tip, so I had to leave the soldering iron on a bit longer just to make sure that the solder actually started to run. You know when you've got a good solder joint, because the solder actually starts to flow. You can see it going almost like a mercury texture. You know, if you're familiar with mercury in a test tube, it's a liquid, and it looks very much like that when it's in its molten state, and then it quickly goes dull after that, and then you know it's cooled down. It's always, you know, you always aim to get the solder to flow. That's what you really want. You don't just put it on for a second and take the heat away. It hasn't had a chance to flow at that point, and you'll end up with what we call a dry joint, or a cold joint, or a cold solder joint, as people call it different things, but I tend to call it a dry joint. It's where you haven't had enough temperature, or there's not enough flux, and you get a bad connection. Anyway, those capacitors are now soldered back in. So this is a standard through-hole component type PCB. It's actually only a single-sided board. This, all the tracks are on the back, and there's just wire on the front. So it's pretty easy to work on a board like that. All you need is a decent desoldering tool and a decent soldering iron, and you're away. You pretty much remove any of the components. Let's suppose we want to do something a little bit more complicated, like what about this connector here? And that's like a multi-pin single in-line connector there. And if you wanted to take that off using the handheld tool, you could do that. You'd have to do every single one, but it would be quite a lot of work to do that, and your thumb would probably ache a little bit at the end of it all. So let's go and get the desoldering tool again, and let's have a go at just removing the connector. Okay, starting at this end here. Okay, they're all desoldered. Let's just see what the status of the connector is. Well, there you go. Easy as that. That would have been a problem to remove with the hand suction unit. So that came out really easy, really simple. Nice clean job. No scratching or pulling of tracks or anything like that. Really clean. Dead easy to put it back and resolder. And if you want to solder it back, well, we'll just stick it back in again. So I'll just tack it in. I'm not going to solder it in properly, I'll just tack it in. That'll do for now, just so I don't lose it. So I've just soldered a couple of pins there just to hold it back in again. And just a quick word about some different types of solder. I've got a few here. You'll notice they come in different thicknesses for a start. You can tell that just by looking at the actual solder itself. They come in different thicknesses depending on what you're working on. This is the thinnest I have. This is a very fine sub 1mm size, very fine, and that's great for like very fine PCBs, computer chip, that sort of thing. Surface mount work, good for surface mount pins, soldering those back on. You know, and it goes up to like thicker sizes. What you don't want is a really thick type solder, like 2mm or 3mm, that kind of thing. You tend to reserve big thick solders for actual mechanical joints. You use very thick solder for instance, gas pipe work, that sort of thing. They're really not suitable for electronic work. It's far too thick, too heavy, and sometimes the solder doesn't actually have flux inside of it as well. These actually have flux built in their cores, what they call multi-core resin. So within the actual solder itself, inside of here, there is actually flux inside of the solder as well. So when you heat up that solder, you're not just melting the metal alloy, you're actually heating up the flux as well, which allows the whole joint to work. You know, you need a certain amount of flux to allow the solder to flow correctly. Without the flux, the solder would just go into little blobs, little beads of metal, and wouldn't really connect the two connections together. So you must have flux in there. And some solders, like I say, for larger mechanical work, plumbing and that sort of thing, they don't actually have flux inside. So for electronic work, we avoid those and we use these. These have all got flux built in. They're just different thicknesses. We tend to use, like I said before, a 60-40 composition, which is lead and tin, mainly lead and tin, and with a little bit of copper in there as well. I think it's only about 1 or 2% copper. It's a little bit, but all this information is on the internet if you want to look at the details of melting point temperatures, that sort of thing. They generally start around about 180 degrees centigrade. Once you get solder up to about 180 degrees, 190 maybe, centigrade that is, it starts to melt. Some of them are higher than that, like 200 degrees, 210 degrees. So it tends to be somewhere between 180 and 210, roughly, where the solder will actually melt. This particular one on the end here is a special solder, and that's a very high melting point temperature. It's about 250 degrees, and that's designed for aluminium work. And I use this to repair speakers, because high quality, expensive professional speakers, they don't just have a copper coil inside, like a voice coil. They actually have an aluminium wound voice coil. You need a special solder to be able to solder them. You can't do it with normal solder. But these other ones, these are all standard solders, different thicknesses, and you just basically choose the thickness of the solder depending on the job that you're working on. And these are all classed as 60-40 tin lead solders with a tiny little bit of copper in there. Of course, you can get unleaded solder as well, which tends to be more and more in fashion nowadays because of the directives of electronic equipment nowadays requires no lead in the unit. So if you buy a device now, like a computer or a laptop or whatever, or any other piece of electrical equipment, they are stated as lead free. You're not allowed to put anything with lead in. So they use lead free solder, and it's basically exactly the same. They look exactly the same. They tend to be in green instead of red, which is handy to separate them. And basically they have a higher melting point temperature. It's roughly about 20 or 30 degrees higher. So where this one might be, say, 180 degrees, unleaded solder would roughly be about 230 degrees, something like that, 220, 230. It's basically, you need a bit more heat for unleaded, and that's really the only difference. Personally, and I think if you ask anybody that does a lot of electronic repairs, once you've had experience of both leaded and unleaded solders, you tend to go, at least I certainly do, and the people that I know in the field, we all tend to gravitate towards leaded rather than unleaded solder, because it does actually solder a bit better. It flows nicer and you get a better finish. The problem is, of course, it does have lead in, and these days lead is classed as a hazardous substance. So whenever you've done work with leaded solder, you must wash your hands thoroughly. I always do this if I've been soldering, like I was earlier. First thing I'll do is, once I've finished doing this video, is go down and wash my hands and make sure you haven't got anything on your skin. Lead's nasty stuff over a long period of time. It's accumulative. You don't want to get it in your body over a long period. It can cause all sorts of health issues. You avoid it. It's fine to use leaded solder. It's not really a problem, but you must wash your hands once you've finished. And with that health warning, let's go to the next section. Talking about wattages of soldering irons, here's a little bit of an extreme example. I actually use this. This is a really useful soldering iron, and you might be looking at it thinking, well, that's a bit big. And yeah, it is. This is an 80 watt soldering iron, which is way too big to, you know, if I was working on a circuit board like this, it would just destroy the board probably. You know, you'd be hitting 2 or 3 contacts at the same time. It would be totally impractical, so you wouldn't use it for that. But where these do come in handy is if you've got power transistors, power regulators, that sort of thing. I do a lot of radio work, a lot of radio repairs, and I use this one particularly for removing RF power transistors, where they tend to be quite big, and they've got like metal tabs, and there's you need a lot of heat to get the thing hot, to heat up the entire area so you can solder it in properly and get that solder to run and flow, you know, correctly, to give you a nice joint. Using a high power iron like this for jobs like that is perfectly fine. In fact, it's even recommended. It's exactly what you want to do. You could use a soldering gun, you know, like a sort of a Weller, one of those soldering guns, or a cheaper one, and that would do it as well. But I tend to like this. It gets absolutely crazy hot, and you've got plenty of heat at your disposal on the tip when you go for the contact, even if it's a large, like a power regulator or a power transistor with a big metal tab on it. If you're trying to use a standard soldering iron, like a 20 watt or something like that, or an 18 watt, it would just suck the heat away. There's no way you'd be able to solder it. So you really need that kind of heat. Okay, so I thought I'd show you that just as a bit of, you know, you wouldn't normally use an iron that big, but they do have purposes when it comes to large contacts and large components where you need a lot of heat. Here's another soldering iron. I've had this for absolutely years. Well, when I started to first get into electronics as a teenager, one of the first soldering irons I ever bought was called an Antex, A-N-T-E-X. And they still make them, as far as I'm aware. So they've been around a long time, these things. And they're always bright yellow, you can't mistake them. And they're actually they're pretty good. This particular one is an 18 watt. So it's a nice heat. That's a reasonable heat for working on a circuit board of that sort of size. That would work well. The only disadvantage with these is you don't have a temperature control. You can't actually adjust the temperature, so you're just relying on it getting hot enough to do the job. And I used to use one of these for years and years, and to be honest, they're absolutely fine. They're not that expensive. Of course, you can get cheaper versions of soldering iron. You can get them down to like £5 and that kind of thing, but generally the elements they don't last very long. That's always the problem, or the temperature's wrong and they get way too hot, or in some cases not hot enough. If you go for one of these types, not the base station one like I showed you earlier with the proper regulated temperature control on the front, where you can get it exactly right, and you can adjust that to the different solders, because some of them have different melting point temperature points. With this, you're pretty stuck at a particular, this is probably it's going to give you about 200 degrees, something like that, so yeah, it'll work fine. 18 watts is the thing to look for. That's a decent power. It's not over the top and it's not too little either. For circuit board use we're talking about, for PCB work. But the fact is, with a decent brand like an Antex, and I don't work for Antex or anything, I'm not getting paid for saying this, but they are a good brand. Rather like a Weller, you could use a Weller iron, which is also a very good brand. What you're really getting is the correct temperature. It's not going to be too hot, it's not going to be too cold, and the elements, the actual heating element inside here, tend to last longer as well. You know, it's false economy to just go out and buy like a £5 special line soldering iron, because the chances are, you know, you'll turn it on one day, it'll just not work. I have seen soldering irons actually explode. You know, the elements just go pop. Best to get if you can, best go for a brand like a Weller is great. They're probably top of the line for soldering irons, or one of these, an Antex. Okay, and these have been around for years and years and years. And these tips come off. You can remove the tip, and there are many different styles of tip, by the way. But you can get fine tips, you know, where it's just like a point, large tips, smaller tips, that sort of thing. You just slip them on. Put it in a spring, coily spring, just to stop it from flopping around. I screwed this onto a lump of wood just to stop it falling about, and it makes it safer. You know, keeps it in one place. It's not falling around. You don't want to burn anything, including your hands. And it's got a little sponge in the bottom there. Put a bit of water in there. You can just give it a wipe every so often, and wipe off all of the, you know, the molten flux and any sort of residue you've got on the end there. Just keep the tip clean. That's a cheaper way of doing it rather than going for the full base station, but not as good as a regulated base station soldering iron, but okay for hobbyist work or just the odd repair. Good for that. Just a quick word about taking care of your soldering iron as well, whether it's a base station type or whether, you know, regulated power, regulated temperature, or whether it's one of these fixed temperature irons. When it comes to cleaning tips, I've seen people clean the tips with emery cloth, sandpaper. I even seen one guy using a file once and cleaning the end off and everything. That's the worst thing you could do with your soldering iron tip, is to use anything abrasive. I've seen these metallic, it looks like springs inside, and you push the iron in and out a few times and it's supposed to take the, you know, take the residue off the end, all the gunk and everything. I don't even like those. What the last thing you want to do is to actually put anything abrasive against the end, which is a tinned solder area. At the very tip, you can actually see it's like a tinned area at the very end. And what you don't want to do is to take off that coating. Okay, that's a solder, what we call tinned area. You don't want to take that away and reveal raw copper, which is what it is. The tip is actually copper underneath that. But you want that tinned area to stay like that. When you're actually cleaning your soldering tip, never use anything abrasive on the end. Don't use emery cloth or a file or anything like that. It's the worst thing you can do. Just put some water on, a bit of foam, you know, just wet your foam there and just give it a wipe like that, you know, and turn it around a little bit. It'll phase. This is cold obviously, but if it's hot it'll phase and you'll get a little bit of steam and that kind of thing, and it'll hiss at you a little bit, and then it'll clean the tip off perfectly. Or just get like a wet sponge, you know, just give it a wipe, give it a quick wipe on a wet sponge. Or you can use a bit of denim cloth, is actually very good. Anything where it doesn't burn, basically. You can just like make it wet and give it a wipe, and that's perfect. But nothing abrasive. Watch out for that if you're cleaning your tip, which you will have to. Usually after every connection, I'm always cleaning my tip, because you don't want any sort of solder residue or flux residue on the end. When you come to do the next joint, all that stuff tends to go onto the board and it makes for a messy joint. Keep the tip clean, nothing abrasive, bit of water, bit of sponge or a cloth, and it's perfectly fine. We've covered through-hole components, soldering and desoldering. Let's have a look at a surface mount board. So here we have a prototype board that I've got for a project from an old project that this is a spare board now. We've got a chip, which is just a surface mount chip, and you can just see it, you just see it there. Okay, so that's our surface mount chip, and what we want to do is just basically plop that onto the board and solder it into position. Now there's a couple of ways we could solder it to the board. We can use a very fine tip soldering iron with some very fine solder and simply solder the pins individually. You can do that, and I use a big magnifying glass, an illuminated magnifying glass to do that. I just get a nice magnified view of the area, and then I can go in with a soldering iron and just using a very fine tip like this one and just go in and solder the pins one at a time, and that's perfectly fine. Now another way of doing it is to use solder paste, which is basically, it is solder but in a paste form as opposed to a metallic form, like a sort of a wire form like what we're used to. You put that on the board and then you can stick the chip to the top of the board, which holds it in place. We can then use the rework station, the hot air gun that I showed you earlier, to heat up the area and melt the solder around the pins. And what happens is when the solder paste actually melts, all of the pins get soldered pretty much all at the same time, so you end up doing all of the solder joints at once. And because of the surface tension between the pins, there's a gap between the pins, it has a natural tendency to congeal against the pin and not the gap. So the solder will collect around the pins and it doesn't like fill the gaps, as long as you don't use too much solder paste. If you use too much solder paste, then the pins will short out. You just have too much, it all clumps together. So the trick is to actually get the correct amount of solder, not too much, not too little. So when it heats up, all of the solder clumps to the pin areas, to the pad area, and not the gaps. And like I say, it has a natural tendency to sort of go that way anyway when you heat it up. When it's hot, you can usually touch the top of the chip, and again the surface tension really pulls the chip into alignment, and it will have a natural tendency to be where it needs to be. It doesn't just like fall all over the place, it actually tends to pull the chip into the right area. So let's have a go, first of all, just soldering the chip on using a normal soldering iron, and I'll show you that next. Okay, so we've got our chip in position here. If you're interested, it's a 74HC74 dual D-type flip-flop. That's what it is. We've got it in position. Really the best thing to do here is to tack on one leg. If you can solder one leg first, that holds the chip in position. I've got some very fine solder here, really fine solder. I'll try and do this and keep my hands out of shot. It's rather difficult. I've got the camera and the soldering iron to operate here, so apologies if this doesn't work perfectly first time. So let's just see if we can tack one leg, and it might move the chip a little bit. Let's see how it goes. I'm aiming to not move the chip. There, managed. So that's actually held it into place now. So now the chip won't like move around on the board. So let's do the opposite corner and just tack that into position. Okay, that's now tacked into position as well. Now what that means now is the chip is actually in position. We can go ahead and do some soldering. Now this is the wrong angle for my soldering iron. I'm looking at the board from an awkward angle, so let's just see how this goes. Let's see if we can actually solder this into position. Okay, give it a go. And you'll notice there's a little bit of white flux residue, yeah, and that's perfectly fine. We're going to wash that off later when we're finished. Yeah, now that's actually soldered, and I'm just retouching it up a little bit. Okay, I'll turn the chip around, and then we can do the other side of the chip. I'd normally be a little bit neater than this, but like I say, it's a very awkward angle with the camera in it and everything. I've also got a light behind me as well, which is stopping me from moving. Okay, that's now soldered. So that's just using a standard soldering iron tip, a conical tip, a very small conical tip, less than 1 millimeter I think it is, and some very fine solder. So I hope you can see you can do this all manually just by, you know, it's just standard soldering technique, but it is actually on a surface mount level. And we could put a capacitor in here and C3 next to it and that sort of thing, and whatever we wanted to do. So that's doing it manually, just use a standard soldering technique. Okay, so let's try soldering in another chip, except this time we'll use the hot air method. We're going to use solder paste. I've got some here. It's if you can see that, it's this is Chip Quick solder. Comes in a syringe and it has a nozzle on the end of it, and we're going to use some of this, which is basically liquid solder, and we're going to put some a little bit of solder along where the legs would be, and that's far too much. Try and put a little bit of solder along the legs. You don't want too much, you just want a little bit. And what I'll do is I'll separate that out in a moment. That's probably enough for now. Let's just remove some of this excess. There's actually there's too much there. So I'm just going to take some of this off, like that. And you can get proper dispensers to give you the exact right amount of solder. Like I said earlier, it's important to have the right amount of solder, not too much, otherwise it'll just all short out. And all I'm doing is taking the excess off here because I put too much on. Simple as that. Let's get a new chip and place the chip on the board. Okay, and try as best as you can to get it into position, roughly where you want it. Stick it down a little bit. There you go. All right, that's roughly in the correct position. So now we'll go for the hot air. I've got it set pretty high. I've got it set at 381 degrees. It's quite high, so I've got to be a bit careful with this, and slowly bring the nozzle closer to the board. So what we're doing is now I'm heating up the chip and the solder. The nozzle's just here. It's just out of shot here, just above the chip. And all I'm doing is like moving the nozzle around the chip. So we're actually blowing hot air onto the chip right now. And you will see it's just starting to go there. Do you see it going? There's the pin soldering there. I'll do the other side. Okay. And I believe we're done. That's it. Okay, so that's the chip now soldered into position using the solder paste and the hot air gun. It's soldered pretty good. I've just had the magnifying glass on for a closer inspection, and I could have done with slightly more paste on there. It's a little bit difficult. I'm working under not ideal conditions here with the camera and the lights and the magnifying glass and everything, so I could have done with a slightly more on there, but that's actually electrically connected, and if I powered that up it would actually work. So yeah, that's actually soldered reasonably well. It's not 100% perfect, but it's soldered and it's on. And I think you can see it's actually a little bit neater than the other chip that we did earlier, where we're just using a soldering iron. So that one was soldered in using a very fine tip soldering iron, and that's fine, it works. But it's not as neat as that. I think you can see that anyway. And this was probably a little bit quicker as well, because the whole thing soldered in one go, whereas this took time to go around all the pins individually, and you need a very steady hand. And one last thing, when you're soldering to a PCB, whether you're doing a repair or whether you're soldering chips directly to a brand new board like I am here, is just get a Q-tip and some isopropyl alcohol. You can get isopropyl alcohol from eBay and all sorts of places. It's not expensive. Get your Q-tip and get some isopropyl on the end, and what you can do is just give it a wipe and take off all of that white dusty stuff that you saw earlier, the flux residue, and you can go around the pins and give it a good old wipe, and that actually takes off the flux residue, cleans the pins. Okay, just give it a good old soak there, and it dries very quickly. It dries within seconds, in fact, and that makes for a neater job. It's a more professional job. You know, you don't want boards looking all gunked up with flux and stuff, and it's just much neater if you can take it all away. You can see the residue on the end there, on the end of the tip. That makes for a cleaner connection altogether there. Okay, so that's a handy tip. Bit of isopropyl alcohol and a Q-tip. Okay, so that's the chips in position. So we've demonstrated how to solder the surface mount chip to a board using a standard soldering iron technique, and also hot air gun with solder paste technique. Now, to remove them, we again use the hot air gun, just like we did to put the chip on. Use the hot air gun here, and I'm just going to heat up the chip, one of them. Actually, the one on the left I'm going to do first, and we'll bring it up to temperature. You don't want to bring it up too fast. Let the board warm up first a bit. So I've got the hot air gun about 1 inch away, and I'm just going round and round, just sort of going round the chip like that, going round the chip until the solder starts to melt. And I've got some very fine tweezers here, which I'm going to pick the chip off once it actually melts. Okay, so let's get the chip warm. There you go, and that's it. And I've literally just picked the chip off the board there, if you can see that. Okay, put that to one side. Let's do the other one. Now, this one was hand soldered, if you remember. So let's but it's the same technique for removal. If you've got components around the chip that you didn't want to damage, you didn't want to get them hot, you can use what's called Kapton tape. Kapton tape is a really useful stuff. It also has very good voltage insulation properties, but it doesn't burn. It has a very high fire point, flash point, if you like. You can get it very hot, and you can use that tape, and you can use it as a protective shield around the components next to the chip, that you don't want to get too hot and burn. And there you are. I've just lifted that, literally just lifted that chip off there, all in one go. Put that to one side. So you're basically heating up all of the pins at the same time. There's the other chip there. So removal is actually really easy. And like you see, you could have the Kapton tape around the areas, like if you had components here that you didn't want to get too hot or anything like that, use the Kapton tape and stick it around the area as a protective area. Works like a heat shield. And you might notice that there's a little bit of excess solder left where we've removed the chip, especially on this one where we had more solder than what we did with the paste. The paste has come off reasonably clean. There's a little bit of excess solder there, but there's more on here. We've got some clumping going on here, and we can remove that using solder braid or solder wick. You know this stuff. It's copper braid. It's got flux in it as well. This is really handy stuff for cleaning up boards after you've done a bit of a repair. Take your soldering iron tip and just run it along the pins like that. Just run it along. Can you see how clean that's gone straight away? It's took off all that excess, and those pads are practically like they've never been soldered to. And that's perfect. Let's do the other side. Yeah, lovely. What about the other chip? Let's move this across a bit. Let's do this one. This one isn't so bad, but we'll do it anyway. Lovely. And the last side. There, all done. And I hope you can see that's where the chips were. That's pretty clean. There's a tiny little bit left, and of course we can go in with our Q-tip and a little bit of isopropyl alcohol, and we can clean up any little bit of flux residue as well. I haven't done that, but you could if you wanted to. Okay, so solder wick, or solder braid if you like, it usually comes on a roll like this. It's really handy stuff, really useful. That's the completed board. We've soldered chips to it, and we've removed them again and cleaned up the board as we went. You'll notice I've got it on a couple of wooden blocks just to keep the heat away from the desk so I don't damage my surface. A little bit of anti-slip rubber under there just to keep the thing stable as well. You can get proper PCB holding jigs with clamps which actually holds the board, and you can angle it. I tend not to bother, but of course you can get them sort of devices which makes your life a little bit easier. Solder braid or solder wick I was showing you for removing excess solder when you're finished. Really handy stuff. And like I say, it's basically just copper braid, but it does have flux in there, and it's important that it has flux in, otherwise the solder doesn't actually get sucked away properly, doesn't flow properly. I could have used Captain tape. This is Captain tape. Looks kind of golden in colour, or brown. It's very sticky. You use it for, like I said earlier, for masking off areas that you don't want to get too hot. If you're doing a bit of rework, let's say, and you want to change your chip and you've got components around that chip, you can get some Captain tape and simply place it around, and it works like a heat shield. So that's really handy stuff to have in your toolkit as well for soldering, especially for surface mount work. And then we've got the solder pastes. I've got different solder pastes. This is the one I was just using. This is Chip Quick, it's called. And again, you can get this on eBay and places like that, and other electrical outlets, specifically for surface mount work. It's a big syringe and it's full of stuff. It's full of paste. You get like a little nozzle with it. It's just like a sort of a, you can use standard syringe needles, but they tend to have to be a certain size. You can't use thin ones because otherwise you can't squeeze the paste through the nozzle. So you have to go for fairly large nozzles to get the paste through. Otherwise you can't squirt it through. You can't get enough pressure behind it. That usually comes as like a kit. You can also get it like this, where it comes in a little tub, little mini tub of it, and that's again, that's a solder paste inside, grey looking stuff. It's sort of it's not a liquid. It doesn't fall out if you tip it. It's not an actual liquid, but it's almost a liquid. It's quite runny, that sort of consistency. You can use that, and you can just, like, you know, use a Q-tip or a very fine screwdriver tip. Use that to put it onto the board when you come to do your soldering with the hot air gun, just like we did with the syringe paste. It's the same paste, it's just a different way of applying it. And the other thing worth remembering is, if you're not using the paste for any amount of time, whether it's in a syringe or it's in a tub, put them in your fridge. I just put it in a polythene bag. This actually lives in the fridge in a safe place, clearly labelled, and everybody knows not to use it as sandwich filler. Okay, so everybody knows what it's about, and it stays in a safe place. The idea is to keep it chilled, keep it cold, and it lasts longer. If you keep it in the fridge, it could last for months before it actually goes off. It does have a certain lifetime. It doesn't last forever. You can't, you know, it won't last for a year or two. If I come back to this in a year or so, it'll be completely solid and dried out, and then you have to maybe try and bring it back to life by putting liquid flux in. You can get liquid flux, by the way, like this stuff, Topnik. That's basically an actual liquid flux, and you can use that. You can put that into your solder and revitalize it again if it's too dry. It's also great for using it on PCBs when you're actually surface mount soldering as well. So yeah, that's handy stuff to have in your toolkit as well. I haven't really showed using that in this video, but you can use it. It is useful, especially for when you remove a chip and you want to put a chip straight back in there without using too much solder or flux or anything. Sometimes you can just use enough flux, plenty of flux on there, and then the chip will solder straight back in where it came out. Usually there's enough residue solder already there, so all you need really is flux and it's enough to resolder the chip back in again. That's more like for repair work. That's the kind of stuff that we're using for surface mount. Very fine tweezers. These are angle tweezers, really useful for picking up components off the board. Fine as you can get. These are like really medical sort of tiny ones. Very sharp tips on the end, and that's what you want for working with fine components. And the other thing I'm using, of course, as well is a big magnifying glass. I've got a huge big illuminated magnifying glass, which is an angle poise, and it goes on the end of a stand here. And when I'm working on boards, I use this all the time to see what I'm doing, because the work is so small and fine. You really need very good eyesight or a nice big illuminated magnifying glass like I've got here. So that's the sort of tools that I'm using for surface mount work, because sometimes the boards are much smaller than this. You've got multi layers of board and all sorts, and via tracks and all via pins going from top to bottom and everything. Sometimes they're a lot more dense than what this is, and you really need either a magnifying glass like that one, or a USB microscope. You can get USB microscopes, and they just plug into your computer and it blows the whole thing right up, and then you can really see what you're doing with your soldering iron tip. And I've got one. I do use a USB microscope as well. I just didn't want to show it on here because it's too much to set up, and to be honest, that's actually taking things even further than what we wanted to. Right, well, I hope that gives you an appreciation for soldering, both through hole type boards, standard PCB, and different types of soldering iron, leaded and unleaded solders, different wattage of soldering irons, and also some surface mount component removal, some rework as well. Clean up the board with a bit of isopropyl alcohol and Q-tips. It's all tools of the trade. That's all the sort of thing. Plenty of small screwdrivers as well. I've got a precision screwdriver set, lots of small tweezers and all kinds of things like that. Things with very small tips on the end, specifically for working on small surface mount boards like this. It all comes in handy. Okay, well, I hope you've enjoyed the video, and thanks very much for watching.